Hello, and welcome to our tour of Ohio's streets and highways from a pavement preservation point of view. I'm Herman Rodriguez with the Federal Highway Administration's Ohio Division Office. As we move into the 21st century, it is clear that the federal aid highway program is undergoing a significant transition from its original focus on new construction to that of preservation of the highway system. So our focus is becoming one of preventive maintenance, that is, planning a strategy of cost-effective means to retard future deterioration and maintain or improve the function of the system. That's a long way of saying the sooner you can fix a problem, the more money you're going to save your community. This video is designed to assist in recognizing the common causes of distress through visual identification and give you some idea of available means to preserve pavement for these conditions. At the end, we'll discuss resources for determining the best, most cost-effective solution for your situation. To host the rest of our program, we've invited Eric Morse, Pavement Design Coordinator for the Ohio Department of Transportation, to guide us through an examination of the stresses in both asphalt and concrete pavements.
Hi, I'm Eric Morse, and it's my privilege to take you on this road tour of pavement distress conditions. When we're through, it's our hope that you'll be able to identify these distress conditions, understand the possible cures for them, and have the resources to determine the best option for your particular situation. First, we want to explore the distress conditions, causes, and cures for flexible asphalt pavements. Let's begin with the general issue of cracking.
Transverse cracks appear at approximately right angles to the center line. They're caused by temperature changes and shrinkage of the asphalt with aging. Cures include crack sealing, chip seals, and thin overlays. Block cracks are interconnected cracks intersecting at nearly right angles, forming blocks which often break loose. These are usually initiated by aging and shrinking of the asphalt and made worse by frost action and heavy traffic. To slow deterioration in early stages, seal coating works. In advanced cases, overlays or reconstruction is necessary. Longitudinal cracks are cracks that run nearly parallel to the center line of the roadway. They can be caused by the deterioration of longitudinal joints formed during construction or by heavy loading in the wheel path. Longitudinal cracks caused by construction joints are a result of inadequate bonding between paved lanes or reflections of joints in underlying pavement. Longitudinal cracks in the wheel paths due to heavy loading are commonly called wheel track cracking. Severe cracking in the wheel path is also known as alligator cracking. Yes, there are alligators in Ohio. This kind of cracking indicates insufficient thickness. While crack seal never cures anything, it will help retard the deterioration of the crack. Multiple cracks in the wheel path indicate a need for strengthening with an overlay or reconstruction. To fix alligator cracks, you generally need to excavate and rebuild base and surface for localized areas. Total reconstruction is required for large areas. You also need to improve drainage. Edge cracking displays longitudinal or crescent-shaped cracks, usually within 1 foot of the edge of the roadway. There are several causes for this, including a weakened subbase at the road edge, heavy traffic loads, poor pavement edge support, and/or poor shoulder drainage. To slow down edge cracking, you'll need to fill and seal the cracks. Multiple cracks may indicate a need for strengthening with an overlay or reconstruction. Widening of the lane to keep the load away from the edge or providing stable shoulders may be necessary.
Let's move into some other ailments that are unique to asphalt pavements.
Rutting is a vertical deformation in the pavement surface along the wheel path, not unlike the ruts that used to form in muddy dirt roads. Rutting is caused by improper asphalt density or lack of compaction. Lack of stone-on-stone contact allows aggregates to float in the asphalt. As the sun heats the asphalt, traffic pushes aggregates around, resulting in common ruts. It can also be caused by a weak subgrade that allows the flexible pavement to sink under the weight of traffic. The solution to rutting is to microsurface, mill and fill, or overlay. Rutting caused by weak subgrade will require reconstruction. We used to call these washboard roads, but corrugations are a series of transverse ridges and valleys at regular intervals. These usually form in areas where heavy truck traffic comes to a forced stop regularly, likewise at bus stops. In a process similar to rutting, an unstable asphalt mix or weak subgrade allows the stopping weight of the vehicles to push the pavement into ridges. Once corrugations start, mill and fill or reconstruction are about your only options. Next on our asphalt road tour is the problem of debonding. Debonding is a condition where the upper layers of the asphalt surface separate from the lower layers. Usually the upper layer then breaks apart and is washed away, leaving a shallow pothole. What causes debonding is improper compaction of the upper layer of asphalt. This allows for air voids that fill with moisture and strip away the bond between the layers. Other causes of debonding can be poor tack coat and insufficient layer thickness. Most commonly, partial depth patches are performed to cure debonded areas. Other treatments include partial depth patches with microsurfacing or mill and overlay. Raveling is the disintegration of the pavement from the surface downward due to the loss of aggregate particles. The primary cause of raveling is improper compaction or lack of density. This provides increased air voids, which fill with water and cause crumbling after freeze-thaw cycles. Other causes include material handling errors during construction that result in an uneven mixture, improper quality control of gradation with clay incorporated into gravels, or the pavement is aged and the binders have oxidized, freeing the aggregates to wash away. Early on, raveling can be cured by crack sealing, chip sealing, microsurfacing, and thin overlay. When advanced, mill and fill is the best option. Next on our tour of asphalt maintenance challenges is the ubiquitous pothole. You don't have to be a highway engineer to recognize them. These are bowl-shaped voids or depressions in the pavement surface. Generally, potholes are caused by excess moisture in the subbase and/or the subgrade. When coupled with insufficient thickness, freezing and thawing of pavement and subgrade, plus the constant loading from heavy trucks, the structure of the pavement simply breaks down and washes away. The only cure for a pothole is to excavate and rebuild localized potholes, including repairing the subgrade and subbase. Bleeding, also known as flushing, is the presence of free asphalt binder in the pavement surface, recognized by the sh sound as cars drive over it in the hot summer day. There are many possible causes of bleeding: a high asphalt cement content, improper type of asphalt cement, improper compaction leaving air voids, high truck counts, and allowing traffic on new pavement before it is cooled sufficiently. The cure to this is spot overlays, microsurfacing, milling, and overlay.
We have named several cures for asphalt pavement distresses. At the end of this video, we'll list resources for details and comparative costs. Remember our philosophy that the sooner you can apply a fix, even if the road is in fairly good shape, the less it will cost your community in the long run. Now it's time to look at the other side of the road, the conditions, causes, and cures of rigid concrete pavement distress. A number of the distresses are similar to those found in asphalt, but because of the rigid nature of concrete, the treatments are quite different.
We'll start with transverse cracking, which looks a whole lot like transverse cracking in asphalt. Cracks or breaks at approximately right angles to the pavement centerline. Slabs longer than 15 feet crack for two reasons: slab curl and curing. For slab curl, temperature gradients in the slab create a cantilever effect that will crack the slab with load. And for curing, as moisture cures out of a slab, the volume decreases. Without contraction joints or saw cuts, cracking is inevitable. Several cures can be applied to transverse cracks in concrete, including crack sealing, full-depth rigid repair, and dowel bar retrofit. Longitudinal cracking is very similar in nature to the transverse problems we just discussed. The primary cause of a longitudinal crack is waiting too long to saw the center joint after placing the concrete. Longitudinal cracks can also be caused by subsoil settlement from improper drainage, utility trench settlement, or frost heave and spring thaw. When these cracks wander through a slab, they're also known as meander cracks. As with transverse problems, maintaining tight joint seals is critical. In severe cases, full-depth joint replacement or slab replacement, including subsurface stabilization, may be necessary. Next is the ailment called pumping. This is the ejection of fine soil particles through cracks, joints, or along pavement edges as the slab moves up and down with load. This is due to the combination of water, fines, lack of load transfer, and loading. When water seeps beneath a slab, the subbase becomes less able to support the end of the slab. so the slab tilts down into the subbase, ejecting the fines. Eventually a cavity is formed and the end of the slab cracks. To cure this problem, several techniques can be employed: undersealing, dowel-bar retrofit, full-depth rigid repair, followed by concrete pavement grinding if necessary. Faulting is the difference in elevation between abutting slabs at joints or cracks. After significant pumping, often the end of a slab will tilt as the subsoil is eroded, leaving a significant mismatch in pavement height. Not only does this cause a rough ride for motorists, but it continues to induce pumping action and becomes worse as time goes on. The cures for this are the same as for pumping: full-depth rigid repair, undersealing, dowel-bar retrofit, and concrete pavement grinding. Next is the condition called transverse joint spalling. This is the breakup or disintegration of the concrete at the joint. Two common causes are improper dowel alignment, which prohibits joint movement, and the lack of a joint seal. If your pavement was originally designed for joint seals, the lack of joint seals will allow incompressibles to enter the joint that can create localized pressures that break the concrete over time. Cures for this include crack and joint sealing, bonded patching, and full-depth patching. Wear and polishing results in a polished surface that can become very slippery in rain. This condition can be quite dangerous. Basically, the traffic wears off the surface aggregates, so a slippery, smooth surface is exposed. To recondition this pavement, either grinding or an asphalt overlay is recommended. Scaling is a surface deterioration where fine aggregates and mortar are lost. This is generally caused by using non-air entrained concrete and de-icing chemicals, or by improper finishing techniques. Several options include grinding, asphalt overlays, a bonded concrete resurfacing, and partial depth patching. Shallow reinforcing is a curious combination of spalling with telltale rust stains in the surface cracks of the slab. The cause for this is the reinforcing steel floating too close to the surface during installation. It doesn't show up until water has had time to seep in and start corrosion in the steel. To cure shallow reinforcing temporarily, an asphalt overlay or patch will suffice. Permanent repair requires replacing the reinforcing steel and making a partial or full-depth repair. The D in D cracking stands for durability cracking. This is recognized by closely spaced, crescent-shaped, hairline cracks occurring adjacent to joints, cracks, or free areas, initiating in slab corners. You can also see a dark coloring of the cracking pattern in surrounding area. Poor quality aggregate absorbs moisture, causing the aggregate to break apart during freeze-thaw cycles. This generally only occurs where moisture is present at joints. For a temporary repair, a partial depth asphalt patch similar to pothole repair can be used. For a permanent cure, a full depth repair is required. With corner cracking, you'll see diagonal cracks near the corner of the concrete slab, usually within 1 foot of the corner. This causes insufficient soil support or concentrated stresses due to temperature-related slab movement. Partial or full-depth patching or full-depth joint replacement will remedy this situation. Finally, blow-ups occur when a slab is pushed up or crushed at a transverse joint. This is caused by expansion of the concrete where incompressibles, such as sand, have infiltrated into poorly sealed joints and is often triggered by hot weather. This is more common in pavements with long joint spacing. To avoid blow-ups, pressure relief joints can be installed. Blow-up areas must be patched or reconstructed full depth.
So there you have the commonly seen distresses and cures for concrete in Ohio. Once again, remember that the sooner you can apply a pavement preservation technique, the less it will cost you in the long run.
Thank you, Eric, for the overview of conditions, causes, and cures regarding pavement distress. We urge agencies to carefully organize pavement preservation planning. By doing that, you will first document actual conditions of pavements. Second, determine causes of those conditions using material given you in this video. Third, plan cost-effective preservation strategies. Fourth, schedule those cures. And fifth, budget for the work. A side benefit from this degree of management is that your local officials can respond more effectively to questions from the public when the officials can refer to detailed and systematic information. A planned approach is easier to explain and receives greater public support. Various states have proven this to be valuable in not only developing cost-effective pavement preservation programs, but in developing a high level of public trust and support. For assistance and more detailed information, contact any of the resources that you'll see in just a few seconds. Thank you for your attention. I'm Herman Rodrigo.